in science and math very easy. And if you enjoyed this tutorial, please, all that I want you to do is to like, share, and subscribe to my channel for more tutorials like this. You can also hit on the notification bell icon so that anytime I post a new video, you'll be notified. This is Richmond once again, and then today's tutorial we are on how you can apply the quotient rule to solve questions. And then if you like this tutorial, please subscribe to my YouTube channel for more tutorials like this one. Okay, so we're talking about the quotient rule. Okay, so when I have y is equal to u over v, what comes to mind? What comes to mind is that I have a numerator over a denominator, or a numerator on a denominator. So please, actually that's what it's going to be. So this is the numerator, this is the denominator. Whenever we express something which can be written as form a numerator over a denominator, because the quotient. So in differentiation, if I have an expression which is occupying the position of u and the other expression occupying the position of v, which are actually functions of x, all I can say that the only formula that I can use to solve this question is the quotient rule. Okay, and then I'm not here to prove the quotient rule. Maybe in the next tutorial I'll do that, but let's actually create the formula here and then we use it to solve the questions. Okay, so in the quotient rule, if I'm asked to find the y, the x of any equation, what I need to do is that the y, the x should be equal to v du dx minus u dv dx all over v squared. So with this, we call it the quotient rule. Okay, so we take some simple questions and then try to differentiate them so that we know how important is the quotient rule. The first question is like this: y is equal to e raised to power x here over x squared. Okay, so all that you need to know is that this one is your u and this one is your v. Okay, so this one is your u, this one is your v. So the formula is v du dx minus u dv dx. So if this one is my v, then I write x squared here. Okay, occupying this one because x squared is representing my v. And then I find the derivative of 2ex. Then minus u, and this is my u, which is 2 e raised to power x, and I find my derivative of x squared all over my v squared, and you know my v squared, this is my v, so my v squared will be x squared like this. Alright, so let's find the derivative here, the differentiation of this 2 raised to power 2 times e raised to power x. When I differentiate this one, I'll get the same thing. I'll get 2e raised to power x, and then this one will remain, so I have my x squared 2ex like this. So if I differentiate this one, this is what I'll get, because this one, that is changing. And then minus here, I have 2e raised to power x like this. And then I differentiate this one, I get 2x. So I get my 2x here simply all over x squared times x. X squared is equal to, we have a power on a power. So the 2 multiply the 2 and we get x raised to power 4 like this. So I can rearrange this one and then I can get, let's say, 2ex s squared minus 2EX and then 2x like this. And look at something here. 2EX is here and 2EX is here. So I can factor 2EX out and then 4 is here. So 2EX, 2e raised to power x here, and 11 is what? X squared here minus 2x here. All over x raised to power 4 at this place. Okay? So here, even at this point, something could be done here. But I can leave it like this, or I can still divide this one by x to the power 4 and divide this one by x to the power 4. And so I get a value that I want to get. So here, I can just leave it like this way, 2ex, x squared minus 2x all over x to the power 4. If someone factorize x out here, it's not wrong. Can factorize x out here and x can come and multiply here. You're not wrong. So if x is factorized, get 2e raised to power x multiplied by x here, and here 11x minus 2 all over x to the power 4. Okay. So let's take the next example and then see how we can also solve it. The next example is y is equal to x to the power 3 over sine x. And all that you need to know here is that this one is your u and this one is your v. So the formula is v, so dy over dx is equal to v du x minus u dv over x over v squared, like this. So what is my v here? My v is sine x, so I come and write my sine x here, and I find the derivative of u. So the derivative of u here will be 3x squared, so 3x squared. This dot means I'm multiplying, so when you see, you don't be confused. I'm multiplying. Minus u. What's the u here? My u is x cubed, so I write my x cubed here, and then I find the derivative of sine x, and that will give me cos x, like this, all over my v squared, and my v squared is what? Is sine square x, like this. So this one I can rearrange it and become 3x squared sine x minus s cubed cos x all over sine square x. So here, what you can do is that you can factorize x squared out. I'm not continuing to that particular point, but what you can do simply is that you factorize x squared out. When you factorize x squared out, it's going to be left with 3 sine x minus x cos x all over sine square x. And that's all that you can do here. Thank you.